And I do want to just show you, I posted, Brayden, you're hilarious. I posted some graph paper for you. So just real quick to show you where that is. When you're in our OMHS class, I'm sure you found this like geometry toolbox tab. This is just where I put a whole bunch of things that I think might be useful for the course. So like Desmos is there, right? And if you wanted to learn how to like use the snipping or screenshot tools. But at the bottom, I put two different types of graph paper. The first type of graph paper is a bunch of coordinates on one paper. And the second one is just plain graph paper. You are welcome to print it as you need to, or if you have other graph paper, that's fine too. Just you might find this very useful as we go through this unit, because we're going to be working with a lot of coordinates in this unit. Okay. Where did we go? Playlist. There we go. Okay, so we are going to be starting a new unit today. We're in Unit 9, and that means the Unit 8 is over. So Unit 8 is over, which means that the Unit 8 test is open for you. There's a Unit 8 review. A lot of students have told me that's very useful. So I recommend doing the Unit 8 review and then taking that test. I think it'll be on your plan tomorrow, since Friday is like an outing day. If you don't take it tomorrow, it'll stay open until the end of the quarter. But you want to make sure you get that done before you forget what we did in Unit 8. Haley says, can we use Desmos to graph too? Yeah, you could. It's going to be a little more challenging when we get to the rotation, and you'll see why. But you could use Desmos. Yeah. All right. So today's lesson has to be a little different because I need to do some funny rotation things. So I'm actually going to share my screen to teach today instead of teaching it straight out of New Row. So let me go ahead and move you guys over here. And then I'm going to share my screen, and I'm going to teach on a PowerPoint kind of. So if you're typing in the chat, that's fine. Just know that you're on my other screen today. Where are we? Share screen. This screen. Okay. All right. You'll see what I mean when I get to that part. But it's just easier to do it in this way today. Okay. So today's lesson is actually called isometries, and I'm going to get back to why it's called isometries once we go over reflections, rotations, and translations. But we're really talking about transformations, right? A transformation, we've heard this word before. Maybe you've heard about it when a butterfly changes from its little caterpillar stage into a butterfly. It goes through a transformation, right? In geometry, we're going to take a shape and we're going to change it. A pupa. Yeah, you got it. We're going to take a shape and we're going to change it somehow. Okay. So an operation that maps is just a fancy word for saying changes an original figure. And that original figure, we're going to refer to it as the pre-image. So what we start with, you're going to hear me call that the pre-image, what it looked like before we changed it into a new figure, and we're going to call that new figure the image. Okay? Hopefully these words are not new, right? These are some middle school standards that we're just going to cover again here in geometry. And in case you don't remember them, here they are. All right, so if we transform a shape, we could change its size. We could change its position. Or we could change its orientation. So we can make it bigger or smaller. We could move it up, down, left, right. We could flip it. And the first transformation we're going to talk about today is a reflection, which I guess will make Navira very happy. A reflection is a flip. We're going to take that shape and we're going to flip it over a line. And that line that we're flipping over is called the line of reflection. Man, that's a creative name, huh? Each point and its image are going to be the same distance away from the line of reflection. Okay. I like to think of that line of reflection as a mirror. Okay. So your pre-image looks in the mirror and it sees its reflection. Right? Picture looking in a mirror and you hold up your hand, right? If you pull your hand back, your reflection pulls its hand back. And if it doesn't, it's really creepy and you're in a horror movie. Okay. If you put your hand forward, like right up against, where's my camera? Right up against the mirror, right? Your hand moves right up against the mirror and you're like giving yourself a high five, right? Okay. So the pre-image and the image, those points are going to be the same distance from that line of reflection. Okay. You might have a line of reflection that's the x-axis. Right? That's the horizontal axis, or the y-axis. That's your vertical axis on your graph. You could also have lines of reflection that are vertical or horizontal lines. So remember way back when we did like parallel lines and we talked about how x equals a number is a vertical line or y equals a number is a horizontal line? If you don't remember that, maybe you write that here. X equals a number that's going to be a vertical line through that number on the x-axis. Y equals a number is a horizontal line through that number on the y-axis. And then another type of line of reflection could be a diagonal line. And really the only diagonal lines we're going to cover in this class are y equals x or y equals negative x. And if you don't remember what those look like when you graph them, let's see here. Just real quick, I'm going to show you what they look like when you graph them roughly. Okay. Remember y equals x, the slope is 1, right? There's really a 1 right there. And the y-intercept is 0. So y equals x is just a diagonal line through 0 with a slope of 1. Y equals negative x still has a y-intercept of 0, but the slope is negative 1, so it's a diagonal line. Whoa, going that way through the origin. There we go. Okay. The good news is you always have graphing calculator available to you. So if you don't remember what y equals x looks like, just graph it on your graphing calculator, and that's okay. Okay. Oh, there we are. So we're going to talk about reflections. Let's practice them. Okay, this is why you want some graph paper if you haven't printed it, because most of these problems are going to give you the coordinates of the points, and you're going to have to reflect or translate or rotate whatever it is that they're giving us. Right now, we are going to graph these points, and then we're going to label its image under the given reflection. Okay, so we are going to take this triangle. Here are its vertices, A, B, C, and we're going to reflect it across the x-axis. So the first thing we want to do is graph those points. Let's see, I'm going to use yellow. We'll use orange so you can see it. So the point -4, 2, 1, 2, 3, 4, 1, 2. Hopefully you remember how to graph points because we're going to be graphing a lot of them here. 1, 2, 3, 4, 7, and 5, 1. 1, 2, 3, 4, 5. It's a really good idea to label the coordinates of your pre-image. So this was A, this was B, and this was C. Because if you don't label them, then figuring out where they go is going to be challenging because you don't remember which one was which. It might be a good idea to use a straight edge to connect them. I'm going to wing it here and hope they look good. Not too bad. All right, I like to highlight my line of reflection somehow, whether it's using a different color pen, using a different style line, maybe a dashed line or something, but just something so I can see that line of reflection. So my line of reflection is the x-axis. So I'm going to highlight my x-axis there. Okay, so my x-axis is in green. All right, so what's happening here is our triangle is looking in the mirror, and the mirror is that green line. It sees its reflection. We have to figure out where is the reflection. So if you just go point by point, A is 2 blocks away from the green line. So that means its new point or its image will be 2 blocks on the other side. And we give it a new name. You see what it says right here? It says A with a little apostrophe. We say that A prime. That's how we would say that. Okay. You're going to hear me refer to it as A prime. So I'm going to label this point A prime. And really the reason for that is because, I mean, if I say A and A prime, it's very clear that A and A prime go together, right? A gets mapped or changed to A prime. Now let's look at B. B is 7 blocks above the green line. So B prime would have to be 7 blocks below the green line. So here's B prime. And C is 1 block above the green line, so its reflection, C prime, will be 1 block below. And I can connect those, and it does indeed look like a reflection. I could fold my paper on my green line, and those points would line up exactly on top of each other. So now to answer the question, we just have to fill in the coordinates of A prime, B prime, C prime. So A prime is at -4, -2. So because that's the coordinate of this point right here. B prime is at 4, -7. And C prime is at 5, -1. I hope that felt easy, maybe even familiar. Anyone in the chat want to tell me if it felt familiar? Yes. Okay, awesome. Thank you. Also tells me that you guys can still hear me, so that's good. Braden, kind of. That rule isn't going to work for every reflection, though. 6th grade. Okay, good. Cool. Let's practice one in where we reflect across the y-axis. Okay. So the first step is always the same. Plot the points they give you. Okay, so we're going to plot the points. I'm going to number 3 right now. I'm going to let you practice number 2 and number 4 on your own. Let's go to number 3, just so you can see an example where we are going to reflect across the y-axis, which will debunk your hypothesis there, Braden. So our trapezoid here, F is at -5, -2. 1, 2, 3, 4, 5, 1, 2. That was F. G is at -2, -2. H is at 0, -6. And I is at -8, -6. All right, well, I did my best on connecting the dots there. So now for our line of reflection, that's the y-axis this time. So that's here, this dude. Oops. All right, now we just have to reflect the points. F is -5 to the left, right? So F prime, its reflection has to be on the other side of the green line, and it's going to be 5 units to the right. 2, 3, 4, 5. There it is. And I label it F prime. G is 2 units away, so its reflection will be 2 units to the other side of the green line. I is -8 units to the left of the green line, so that means its reflection will be 8 units to the right. And now H. H is interesting. How many units away from the green line is H? 0. So that means that it doesn't move. H and H prime are in the same place. So it stays there. Very good. And now we just have to fill in the coordinates. F is at 5, -2. G is at 2, -2. H is at 0, -6. And I is at 8, -6. Yeah, Braden, so you were right. If you have kind of figured out like a trick to this, that's okay. Just watch out because we're going to start changing the line of reflection and it's going to be a little different for you. Okay, let's see what happens if the line of reflection is not the x or the y-axis. What if it's just a vertical or a horizontal line? Okay, well, we're still going to graph those points that they give us. So I'm going to start there so we know what we're working with. Let's see, J, so I'm on number 5. J is at 1, -1. K is at 2, 3. 2, 3. L is at 3, -2. And it's just a triangle. That's nice. Okay. And now we're going to reflect it across the line y equals 4. Okay, well, y equals 4. That is a vertical line. And it goes through x equals 4. So I'm going to find where x equals 4 on the x-axis. 1, 2, 3, 4. That's right here. And it's a vertical line through there. I did my best. Okay, so there's the mirror now. Okay, so now I say, oh, well, L is 1 block away from that green line. So that means its reflection, L prime, is 1 block to the other side. J is 1, 2, 3 blocks away. So its reflection will be 3 blocks to the other side. And K is 2 blocks away. So its reflection, K prime, is 2 blocks to the right. Okay. And now you just have to find the coordinates of each of those points. So K prime is now at 6, 3, 6, 3. J prime is at 7, -1. And L is at 5, -2. Okay, so if you follow the same process, there's no rules to memorize. I don't like memorizing rules. I'm teaching this entire lesson so you don't have to memorize rules if you don't want to. I hate having to use that M word, memorize. Who wants to do that? It's just easier if you know what's going on, right? Okay, so that would work. I'm going to let you practice these on your own, but I just want to graph the line of reflection here in number 7 for you. I think that we're catching on. So in number 7, I'm not going to do the whole problem, but let's just at least graph the line of reflection. Y equals 2. Y equals 2 is a horizontal line. And that's going through the y-axis at 2. So if you find 2 on your y-axis, that's where your horizontal line will go through. Okay, and then everything else is the same. Graph your points, count how many blocks away from that green line it is, and then find its reflection on the other side. And then you'll write the coordinates of those points. Very good, Haley, you're right. Navira, you're right. Okay, let's look at an example where their line of reflection isn't a horizontal or a vertical line anywhere, but it's instead a diagonal line. So let's look at this one. I'm going to graph its vertices. So -5, -2, 1, 2, 3, 4, 5, 1, 2. -3, 4. This is x, this is y. Z is at -1, 1. Nice. Here we go. So the diagonal ones are tricky, but they're not, I don't think they're hard if you know what you're doing. I'll show you the trick and maybe you'll like it. Okay, we're going to graph the line y equals x. This is a line that goes through the origin and it has a slope of 1. So as carefully as I can here. There we go. That's as straight as I possibly could get that. Best to use a ruler, of course. So this is now the line of reflection. I want to be able to fold my graph on that green line and know where would z fall, where would y fall, where would x fall. Okay, we're going to kind of travel back in time for a moment to when we talked about parallel and perpendicular lines. If I have a line with a slope of 1, and then I have a line that's perpendicular to it, what is the slope of that perpendicular line? Yes, good job, Lydia. Anyone else? Faith, you're right. Valerie, yeah, you got it. Yes, all right, I'm seeing lots of -1s. You're right. Okay, and why is that important? Well, because that is going to be the slope. If I were to connect z to this green line, it needs a slope of -1. Okay, so do you see how z is like 1 block away from the green line, just on the diagonal? That means that z prime is going to be 1 block away on the diagonal. So z prime will go here. Y, I'm going to use a different color so we don't get too confused. Blue. Y is 1, 2, 3.5 blocks from the diagonal. So now I'm going to go half a block and then 1, 2, 3. And this is where our y prime will be. Orange. And then x. X is 1.5 blocks away. So then I have to go the half and the 1 block, and there's your x prime. So you're still counting the spaces. You're just counting the spaces on the diagonal of a -1 slope. And then you just have to find the coordinates of your new points. So x prime is there at -2, -5. Y prime is here at 4, -3. And z prime is 1, -1. Yep. So instead of counting the blocks up and down or left and right, you just have to count the blocks along the diagonal. And that's okay. We'll do another example. Let's go down to number 11, where we can do an example with a negative x. So first I'm going to graph the points -1, 3. Label it A. 0, 6. B. 3, 5. C. And 2, 2. There they are. Ooh. Clearly, I just can't connect the dots. Let's try that again. There we go. Okay, we're going to graph the line y equals -x. This time, the slope is -1. The y-intercept is still 0, so it's just a diagonal line going through the second and fourth quadrants. So I'm going to, can I make a line? It'd be so much easier. Oh, that's not helpful. Oh, look at that. All right, so there's our line at y equals -x. Now we just have to figure out where would A, B, and C land if I folded it on that green line. I want to make sure that my green line is exactly where I want it to be. There we go. Okay, so now A is 1 block away. So A prime has to be 1 block away. B prime, I'm going on a negative, or yeah, on a 1 slope here. So 1, 2, 3 blocks away. So B prime has to be 1, 2, 3 blocks away. D is 1, 2 blocks away. So D prime will be 1, 2 blocks away. And this is on the diagonal, of course. And C is going to be 1, 2, 3, 4 blocks away. So C prime, 1, 2, 3, 4. So here is your new shape reflected across that line. So A prime lands at negative 3, 1. B prime lands at negative 6, 0. And C prime lands at negative 5, 3. D prime lands at negative 2, negative 2. I highly recommend making sure you practice those, making sure that you can get that reflection. The blue square looks messed up because I didn't draw a straight line. Sorry, Tia. Here, I'll try again. There you go. Yeah, you do kind of form a 3D shape when you do that, don't you? Okay, so that was reflections. The next isometry that we're going to talk about is called a translation. Okay. And we probably heard this word translation before, right? Like if I said, me llamo Mrs. Grandy, you translate to, her name is Mrs. Grandy, right? You can translate languages. You can translate, like sometimes I have to translate your little symbols over there, like X-X. Is that like, I don't even know what that means. Or I have to like NMV or NVM, right? I translate that in my head to mean, oh, never mind, right? Or if my brother texts me, I have to translate all the emojis that he uses, right? Well, we're going to do some translations here, but more for geometry. And the translation really means we're going to move it left and right or up and down. So it's a little different than the translation that we already know. I like to call a translation a slide. We're going to slide our figure. Symbolically, it'll be given to you like this. It'll say, oh, you have this coordinate, x, y. You're going to map it. We've seen this arrow before. It's a little different now. Map it or change it or move it to a new point where we're going to take our x value and we're going to change it by some number h. And then you're going to take your y value and change it by some number k. That h is going to represent your horizontal shift, how you move it left and right. So are you moving it left and right, maybe? And the k is going to represent your vertical shift. Are you moving it up and down? Y, K, and not V. So we're using H and K here because when you get to Algebra 2, you're going to learn all kinds of shifts. And all of those rules have a horizontal shift of H and a vertical shift of K. Yeah, so we're just going to, I'm sneaking it in there. I'm being sneaky and you caught me. You could use any letter you want. And in fact, this is probably going to be the last time you actually see me use the H and the K because I'm going to replace them with all numbers. You don't have to memorize anything with the shift because it's going to give you the rule. Yeah, pretty much, Max. Yeah. Okay. You don't have to memorize anything. I'm going to give you the rule and it's going to tell you exactly what to do. Okay. First thing you want to do, though, is graph those 4 points. So let's graph the points Q, R, S, and T. Negative 6, 1. R is at negative 3, 1. S is at 1, negative 5. And T is at negative 2, negative 7. Did I do something wrong with my R? No. 1, negative 5, negative 2. Something is not right here. What did I do with my R? 1, 2, 3, 1. Okay, maybe my Q is wrong. I did. No. 1, 2, 3, 4, 5, 6, 1. Oh, yeah, Q is at negative 6, negative 1. There we go. I knew that looked weird. Why did I know it looked weird? Because it said it was a rectangle, and that clearly was not a rectangle. Negative 6, negative 1. There we go. That's better. All right, now we're going to translate this thing using this rule, okay? So what this rule says is you're going to change your x. You're going to change your x by positive 5, and you're going to change your y's by a positive 7. So what you're going to do, you're going to say, oh, that whatever I'm doing to the x, remember x is your x-axis, your horizontal axis, that's your left and your right. So we're going to move this thing right 5. And I know it's right because it's positive. And then your y, that's your up and down. So I'm going to change it by 7. And since it's plus 7, that means I'm going up. So you're going to take your point, each point one at a time, move it right 5 and up 7. So I'm doing it the visual way, and then I'll show you kind of like the algebra way in a second. Okay, so we're going to go right 5, 1, 2, 3, 4, 5, and up 7. 1, 2, 3, 4, 5, 6, 7. And there it is, and we name it Q prime. R, you're going to move it right 5 and up 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. T, we're going to go right 5. 1, 2, 3, 4, 5, and up 7. 1, 2, 3, 4, 5, 6, 7. And S prime. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And there is your new shape. See, no memorizing at all. You just have to know that with your x value, you're either moving left and right, depending on whether it's a plus or a minus. And with your y value, you're either moving up and down, depending on whether you have a plus or a minus. Now, if you wanted to do it the algebra way, what you could do is you could say, okay, Q is at the point negative 6, negative 1. I need to change it so that the x value has a plus 5 with it. So the x value of Q is negative 6. Negative 6 plus 5. The y value is negative 1, so I plug that in for y, negative 1 plus 7. Okay, so here, there's your plus 5, there's your plus 7, and then this negative 6 and the negative 1 came from the coordinate of Q. So Q prime is really, well, negative 6 plus 5 is negative 1, and negative 1 plus 7 is positive 6. It's at negative 1, 6. And if you were to look at your graph, negative 1, 6, there is your Q prime. So you can graph it and just count the blocks, go right 5, up 7, or you could actually add 5 to your y value and add 5 to your x value, add 7 to your y value, and get the same thing. I like the counting blocks way, but you can do it the algebra way. That's okay too. Let's do an example where they're not plus signs. So let's go down here to number 4. Okay, so I'm skipping down here to number 4, just so you can see an example where we have an x minus 7 and a y minus 6. So I'm going to graph the points 1, 7, 6, 5, 4, 0, and negative 1, 2. Okay, so there's our original square. And now we look here and I say, oh, this says x minus 7. So with the x value, that's my horizontal, my left or my right. And since it's minus 7, I have to go left 7 because it's a minus 7. With the y, that's my up and my down shift. So since it's minus 6, I'm going to go down 6. So each point I'm going to take left 7 and down 6. So left 7, 1, 2, 1, 2, 3, 4, 5, 6, 7, and down 6. 1, 2, 3, 4, 5, 6. So W prime ends up at -6, -1. Did I count wrong? Oh no, -6, +1. There we go. The other way that you could do it is you could say, okay, well, W has a 1, 7. 1 minus 7 is -6, and the Y value is 7. 7 minus 6 is +1. You could do that too. I'm not going to do the rest of these points because I do want to make sure that we get to cover how to write this rule, and then we've got one more isometry to talk about. So we're going to move on here to actually writing the rule. Oh, there's more examples for you. There we go, writing the rule. So I'm moving on to number 7 here. What happens if they give you the pre-image and the image and they say, you tell me the rule? In all of these previous examples, they're telling us the rule. X, Y goes to, and they give you the rule, right? But now we are going to write the rule. You have power. One thing that you have to remember is that you always go from your pre-image to your image, not the other way around. So what you want to do is pick one of the coordinates here. It doesn't matter which one. Pick whichever one you want, D, E, or F. I'm going to pick F. Okay. F goes to F prime, not the other way around. So I'm going to say, oh, well, F is right here. It's at the coordinate -1, -3. That goes to F prime. F prime is 1, 2, 3, 4, 5, 6, 1. I should have written that over here. -1, -3 is moving to the point 6, 1. So your rule is going to say, okay, well, your point X, Y gets mapped to. Now, how do I go from a -1 to a +6 on a number line? What do you need to do to a -1 to get -6? +7. So this becomes X plus 7. And then how would I go from a -3 to a +1? +4. Very good. So this becomes Y plus 4. The other way that you could do it is you could count the blocks. I went 1, 2, 3, 4, 5, 6, 7 to the right. 1, 2, 3, 4 units up. So I went to the right 7 and up 4. So that was a +7 since I went to the right and a +4 since I went up. If you had to go left or down, those would just be minuses. Okay. The biggest mistake I see students make on problems like this is they accidentally start at the F prime and go to F. So then their signs are wrong. So just watch out for that. Okay. There's some more practice problems with you there where they actually have reflections and translation practice for you. So you would do the, whatever it does, it says an A first, and then take that shape and do the second transformation. I want to make sure that we cover rotations. This is the whole reason why I need to use my PowerPoint. So let's go to rotations. A rotation is a turn. We're going to take our shape and we're going to turn it. The center of rotation for this class is always going to be 0, 0. So it might say around a center of rotation of 0, 0. Okay, cool. If you're an honors student, there's some honors content where the center of rotation is not 0, 0, and you've got some videos for that. But for everyone else, center of rotation will always be 0, 0. And let's see. Oh, the figure will always rotate at a specific angle and direction. Okay, so the angle for us is going to be a 90, a 180, or 270. And we're always going to rotate counterclockwise unless it says otherwise. Remember, counterclockwise is the opposite way that a clock goes. So this is counterclockwise. There are some rules for this that you could memorize. I don't want you to memorize them. I want to show you actually what's happening. And then at the very end, I can come back and put the rules here for you. But first, I want to show you what's actually happening in our rotation. Okay, so we can come back to this if we need to. Okay, so we are going to have a triangle with the vertices. So let me go ahead and graph those. 2, 7, 6, 5. I think I put that in the wrong spot. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, yeah. And 4, 1. 1, 2, 3, 4, 1. Now, notice that we are in a coordinate grid, right? Coordinate grids have 4 quadrants. And if I were to turn it all the way around, I've turned 360 degrees. So that means that each quadrant, each turn is worth 90 degrees. So a 90-degree turn is, I'm going to call that one turn. So it's going to turn one time. 180 degrees is going to be 2 turns, and 370 degrees will be 3 turns. And if you turn 4 times, well, then you're back to where you started. You're going to see what I mean here in a second by that. Okay, so what I'm actually going to do is I am actually going to turn my paper. Okay, I can't turn my computer screen. That wouldn't work. And when you're taking the SOL, you're not allowed to like pick up your laptop and turn it. But maybe you would put this on a piece of graph paper. And then you can turn your graph paper. You're allowed to do that. Okay, so here it is. I am going to physically turn my paper one time to the left. So now my paper is sideways. Okay, why would I do that? Well, now my shape has been turned, and I'm going to pretend that this is how it's supposed to look. Like right now, I'm pretending that this is my y-axis and this is my x-axis. If that was true, what would be the coordinate of A? What would the coordinate of A be if it looked just like this? Anyone can answer in the chat. Right now, if I gave you this paper and I didn't tell you I'd turned it or anything, what would, all right, good. -7, +2. Okay, so A prime is -7, +2. Cool. Now we're going to do the same thing for B. What would B's location be if it was supposed to look just like this? Well, it would be at what? -5, +6. And C, well, that would be at -1, +4. But that's not really, right? That's not really how it was supposed to look. So we turn our paper back the way it was supposed to be. But now we know the coordinates of our new points. A is at -7, 2, or A prime is. That was where A prime landed. -5, 6. That's where B landed, so that's B prime. And C is at -1, 4. So there's your shape rotated without having to memorize any rules. All you have to do is turn your paper however many times you need to, figure out what those coordinates are, and then turn your paper back and graph them. So Lydia, you're thinking in terms of memorizing rules, and I'll give you those then. You could do that. I just don't like memorizing stuff. All right, let's do another one. Let's do a 180. 180 counterclockwise and 180 clockwise is going to be the same thing because it's 2 turns. Okay, but if you want to write that, so 90 degrees was 1 turn. So you turn it 1 time to the left. 180 is going to be 2 turns. So we're going to graph, I can't spell turn today. We're going to graph our points, 2, 6. Could you transform that instead? Well, that's what I'm doing, a transformation. This transformation just happens to be a rotation. Maybe I misunderstand your question. That's okay. Okay, so where are we? Q, 6, 5. 1, 2, 3, 4, 5. 5, 1. 1, 2, 3, 4, 5, 1. And 1, 2. There's S. Okay, there's your shape. And now we're going to turn it 2 times. So this isn't going to be quite a reflection. It's not going to be a reflection. No. It's going to be a good old rotation. Okay, so here we are. Here it is. And you're going to turn it 2 times. So once it would look like that. Twice your paper should be upside down now. Okay, your paper should be upside down. So now our shape is down here in the third quadrant. Now you have to pretend that this is what the graph is supposed to look like. Okay, if this was how the graph was supposed to look like, what would be the coordinates of these 4 points? Well, S would be at -1, -2. So S prime is at -1, -2. P, that is at -2, -6. So P prime is at -2, -6. Q, that's at -6, -5. And R is at -5, -1. Nope, not yet, Nashmia. And then you turn your paper back the way it's supposed to be. And now you can plot those 4 new points, -2, -6. Label it P prime, -6, -5. Q prime. R prime is -5, 1. And S prime is at -1, -2. Oh, did I write this wrong? R prime, what's it? Oh, it was a -1. Silly me. And there it is. Rotated. I will get there. Give me. Okay, so there we have seen a rotation, we've seen reflections, and we've seen translations. All of your rotations is pretty much how it's going to be. There's a lot of practice problems there for rotations. You might want to print it out so that you can actually turn your paper. Okay, now I keep calling these things isometries. Why? Why do I call them an isometry? All right, so let's talk about the 3 types of transformations we've seen. We started with, where'd it go? There, we started with a reflection. In our reflection, you had a triangle and you flipped it across the line. What can you tell me about my pre-image and my image? Are they the same size? Are they different sizes? They're congruent. They're the same size. Okay. Then we talked about translations, where we took our shape and we moved it left, right, up, and down, or a combination of those. Looking at your image and your pre-image, are they the same size or different? They're the same size. They're congruent. And then we talked about rotations. And if you want to see the rules for those rotations, you can check the key on OMHS. I do not advocate making you memorize stuff. If you want to memorize the rules, that's okay. It's not wrong. It's just better if you know what's going on. But when we take our pre-image and we rotate it, they're the same size. Yeah, you knew what I was going to ask. So these were all isometries because no matter what I did to them, my pre-image and my image were congruent. So if you hear that word isometry, let me write it down here. Where'd it go? It's on the key. All right, we'll put it here. If you hear that word isometry, that means that your pre-image is congruent to your image. They're the same size. No, we're going to do the one that changes sizes next time. Yep. Okay. So today's attendance word is, where's my highlighter? There it is. Today's attendance word is, I forget already. Here it is. Translation. Translation is your attendance word today. Make sure you spell it right. So if you hear the word isometry, all that means is your pre-image and your image are exactly the same size, just something's happened to them. They've been rotated, they've been flipped, they've been turned, but their sizes haven't been messed with. There's a lot of practice problems in today's notes that I didn't get to cover in class. These are really good practice problems for you. I highly recommend it. There's also practice problems, like additional practice problems on OMHS, if you want to check those out. Where did my stuff go? All right, and that is the lesson. All right, I hope you guys have a great day. I hope you learned something. Make sure you practice and don't forget to prepare and take your Unit 8 test. I'll be in office hours on Tuesday at noon if you need anything, and you're always welcome to email me. Bye, guys.